Welcome back, everybody, to Young Engineers of Today. I hope you're ready to get started on Python, and I hope you are excited to start learning about how to code. Now, Python is actually a pretty excellent programming language to learn to start out with. It's very close to the English language. That is to say, it doesn't have a whole lot of, abbreviations and superfluous punctuation thrown in and stuff like that. I mean, you'll see a fair amount in Python, but it'll make sense, hopefully. And also, it's not nearly as busy with its punctuation as a lot of other programming languages can be. In addition, it can be used for a few different types of language paradigms, programming language paradigms, I should say. So, we'll hopefully get to see a little bit of each of those as we progress through Python. If we don't, that's fine. Hopefully I can give you guys the foundations so that you can understand what, if you continue your programming journey, you can understand what people or books or whatever might be talking about when they refer to these sorts of things, or at least you can understand the basic concepts, so when you see them later, it's not totally foreign to you. But yeah, we may not get the ability to see everything when we're learning Python this semester. Hopefully, we get to see a fair amount though. So anyway, like I said earlier, Python is also great because you get to explore a few different programming language paradigms. And that sounds really kind of buzzwordy and I don't really want to deal with that. But in actuality, it's something you'll see a fair amount. It's one of the defining things between different types of programming languages, although there is one which is far more prevalent nowadays than another. And I'll get to that explanation in a minute. But it's good to know where they both come from, what the advantages of one might be over another one, and also to be able to understand it if it's ever used in a conversation around you, or have you able to talk about it at some point. Because that's another thing. Once you've got something like that you've just learned about, to be able to talk about it with other people, it's kind of cool. It's kind of cool. So anyway, Python. The programming language paradigms I'm talking about are object-oriented programming languages and function or procedure-based programming languages. Now, some of you were in my classes last year, so you may have heard me talk about this kind of stuff, and I apologize if I am retreading old ground. Hopefully, though, it'll be a reminder or a review for you, and it'll be interesting to hear again, and maybe it'll make a little bit more sense this time around. I don't know. Whenever I hear things, a second time, they tend to make more sense. And for those of you who have not heard it yet, hopefully this all, makes sense. So anyway, at its most basic, all programming languages are basically a procedure-based program, or language, in the sense that the computer goes from top to bottom and executes instructions more or less in order. I don't know if you guys have seen like an example like this one, as I write it poorly in all caps. But sometimes, when people talk about programming languages or whatever, this little example pops up where you got the 10, the 20, and the 30, and then you've got some really simple set of commands like print hello and then go to 10. Now, this is an example of something called BASIC, a very, very old programming language as far as computers are concerned. It's about, I want to say, 30-ish years old, 25 to 30 years old at least. And it's one of the original home computer programming languages. It used to be that you could get magazines in the mail which contained a few pages that just had lines of code in them, and if you put the code into your computer, you had a new game, and that was the original distribution method. We complain about how long it might take to download something nowadays, but at least you didn't have to code it into your computer and then compile it. And if you messed up on, line 263 or whatever, good luck going through your entire code and figuring out where the error was and comparing it with the magazine. But at the end, like I said, you would have a nice, cool new video game to play with. And programs were simple enough back then that you could do that. Anyway, this is, like I said, an example of a procedure-based programming language in the sense that you start at 10, then you go to 20, and then maybe you go to 30, and then you go to 40, and you go to 50. For some reason, they numbered them in tens. I don't entirely know why. I think maybe it had to do with the memory slots, but don't even worry about that. That's just me musing. Anyway, you'll notice it's also fairly straightforward. You start at 10. It says print hello. What does the terminal do? Well, it prints hello to it. Boom. And then you get to the next instruction, which says go to 10. As you might imagine, it goes back to 10, prints hello. Goes to 20, goes back to 10, prints hello, goes to 20, goes back to 10, prints hello, and so on and so forth. You get the idea. Basically, it was just, it's like if you've ever gotten something from IKEA and like a table or something like that, and then you get that little booklet of instructions and you just follow the instructions one right after another, or you get like a Lego set and it's meant to build like a Y-wing or something like that, and so you get a whole bunch of Legos and then you get an instruction booklet telling you how to build the Y-wing in order, one step after another. It's all very regimented, it's all very linear, meaning, you know, there isn't a whole lot of room to sort of branch out to different options. Now, there is that possibility, of course. There are commands built into BASIC, and a few other programming languages which are more procedural, which allow you to jump to different parts of the program. There's actually an example right here, go to 10. It tells you to go to line 10. You could say go to 40, and you would skip 30. You could say go to 70, you'd skip 30, 40, 50, and 60. You could have one in line 70 which tells you to go back, and you might have something that says if this value is true, like you could say if the hero holds the orb of Thalamus or something, then go to line 110, which basically just prints you in, or whatever. Point being, it doesn't necessarily have to go exactly in order, but there isn't a whole lot of wiggle room to kind of like repeat any code or jump around or anything like that. But this is the way that programming had been for a very, 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 very long time. Maybe there were one too many varies in there, but it was pretty close. Anyway, part of the idea behind programming is a more efficient way to model the world around us. So, why don't you guys think about this for a second? If you were to think about the world, the universe that we live in, basically everything, what could you say is everywhere, at least in your life? What do you encounter every day? What do you look at or talk about or think of? And I'm speaking in a very broad term here, so you can be as broad as you'd like. Okay, code and electronics. I like that. Think even more general. What about trees? What about dogs? Okay, air, in addition to all this other whatever, life. Okay. Now think of it in terms of like units, like a dog, or a computer, or a bike, or a thought. What about that? What could you call all of that stuff? I mean, you could call it stuff. That's true too. What about the matter? Okay, excellent. What about objects? And this was kind of a trick question on my part because or like things, maybe. Like you can think of them as things. Maybe they're not all tangible things. Like an idea is a thing, but it's not necessarily a tangible thing. Air is a thing, although it's just kind of everywhere. The earth is a thing, albeit very, very big. A bike is a thing. Stars are a thing. if you really wanted to get abstract about it, you can almost kind of say that emptiness is a thing. It's just more of a concept that exists in our heads. But that's getting a little bit too abstract for what I'm looking for right now. Anyway, one could argue that our entire world, our entire universe, in fact, our perception of everything, is neatly divided into things, or, in programmer speak, objects. Which is where object-oriented programming languages come in. Object-oriented programming languages there were ones before C, but C was really the first one that made it kind of like a more popular thing. But the whole idea behind object-oriented programming languages is, let's say this is our procedural-based programming language over here. Ye olde list of instructions. And they're all numbered. And you've just got, you know, blah 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 blah, like all these different instructions all in a row, and you kind of go from top to bottom. Now, what about this? What if you had an object here, and it had some code in it? And what if you had another one over here, and it also had some code in it? And what if you had another one here that had some code in it, and they all kind of talk to each other? Like they all had their own instructions, and sometimes they could call instructions from another one, and then that one could send instructions back, and then this one could talk to this one, which would talk to this one, and then everything gets kind of sent back. Basically, it's kind of less centralized. Like there isn't one big list you go down from top to bottom, maybe with some, you know, jumps back or jumps forward hidden in there or whatever. It's all more kind of fluid and moving around. Does it sound confusing? It might a little bit, but let me break it down a little bit further and go into the types of things that might go into an object. So we're all familiar with instructions in a code, right? Like that go to 10 example I had, or that print example that I had. Those are specific things which tell the computer to do things. To do things. They're also known as instructions, or expressions. Although expressions is a little bit too general, but it's close enough. But basically, they're instructions. You've also got another one called variables. Now, you guys have been through algebra at this point, if I'm getting my order of mathematics correct. I believe you hit pre-algebra in 8th grade, I think. I don't know, maybe it's been a while. It's actually been, well, 15 years since I was in middle school, if I really wanted to, you know, show off my age. But anyway, I think it's in high school you start encountering algebra, and certainly, at least in pre-algebra, you start looking at variables. Now, variables, as you guys know, can represent a number. So you can say like x equals 8 plus 6, and then it's kind of like, oh, well, what is x? And you go, it's 14. You know, it's an easy problem. You know, addition, whatever. Then things kind of threw you for a loop when you got stuff like x equals 2 plus y. And now you go, okay, what's x? It's like, all right, well, now this is a little bit more complex because it depends on what y is. Y could be 6, so then x will be 8. Y could be 7, so x will be 9. Y could be 23, so x will be 25. You get the idea. Point being, once you reach this area right here, like this kind of a thing, like this top one, x can only mean one thing. It has to mean one thing. It has to mean 14. Otherwise, math is broken. And we really don't want to break math. With this one down here, now x and y, they can equal whatever you want them to. X is dependent upon what y is, but y can be anything. By that same token, because y can be anything, x can also be anything. It's just anything with an asterisk next to it. But anyway, you guys already knew that. Computer variables are kind of the same thing, except they serve like a more functional purpose. So like let's say that this x existed as a computer variable. Well, x's life as a computer variable is just an open space in memory. It's not like necessarily part of a mathematical equation like what we have here. It doesn't even necessarily have to have a number in it. It can have a letter, it can have a word, it can have just like a true-false value. But it is a space reserved in memory with a name, in this case x, that can hold stuff. And the big thing to it is that stuff can change. You can set x equal to equations, and you can set x equal to numbers or whatever, and change the value of x over time. The value of x can change a billion times during, one run of a program, if you run it for a while. But it could theoretically do that. It could change one time. It could change never. Something could never be put into x. That's also possible, although not necessarily the best programming practices. But anyway, the entire point is, it is a slot in memory where you put stuff. You can also think of it like a box where you put stuff into that you need to keep track of. It's like you're working on a car, and you've got a crescent wrench, and you got to come back to the crescent wrench periodically in order to do different stuff, like tighten some various nuts or whatever. And in the meantime, you're using a screwdriver to take out some screws. But you still need the crescent wrench eventually, so you throw the crescent wrench into the box so that you can access it later and use it for other stuff. It's kind of the idea behind a variable. A variable stores properties and takes up some computer space, some memory space in order to do it. Now, relative to the amount of memory that your computer has, it's very, 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 very small. I mean, ridiculously small. You could make so many variables before your computer starts to fill up, which, as you get further along in programming, trust me, you will do accidentally at least once. And that's just going to happen. And then you'll feel like, a computer wizard when that happens, because you've managed to tinker around with the software parts of the computer so much that you broke it. I mean, not permanently. Computers are kind of nice and easy to break because usually you can just hit the restart button if things go really, butt up, and things should go back to normal. Just don't do that too often. But anyway, variables. Let's say like x, or like y, or like z, or whatever. Okay, so how does this relate to what I was saying before about the world being made up of stuff? Well, let's take an example of an object called a class. A class is basically a block of code that can have both variables and expressions in it. It can also be instantiated in order to create more of its kind. And I'll explain what all those things mean in just a moment and what it all amounts to. So let's take, I used this example in my 5 o'clock class, so let's just do it again. Let's take an example of an object in real life. A car. Give me some examples of properties that a car might have. Like, what can be different about cars? If you took one car and another car, what could be different about those two things? Give me some examples. Okay, we got size. Cool. What else? How about color? Perfect. I like color. All right. Color's another one. All right. How about like make and model? Excellent. Nice. Nice timing there, Kai. Maybe you could say number of doors. There you go. That's another one. Say manual or automatic. So these are things. Yeah, used or new. There you go. Perfect. Perfect. These are all things that are kind of common to all cars, but they can be different from car to car. You know, a car can be a different size, it can be a different color, it can be a different make, different model, have a different number of doors. It can be manual, it can be automatic. It can be used or it can be new. Sensing a trend here. These right here could be variables. How about this? What can cars do? I mean, assuming that a car is working, what can it do? It can drive, exactly. What else can it do? Accommodate passengers. Let's say have passengers abbreviated. There we go. But nice wording. What else? We could go even obey commands. Okay. Yeah, we could go even simpler. We could say like honk horn, lock, unlock doors, turn on, charge battery. You know, because like the alternator does that. But all of these things are also possible, assuming you have a fully working car. Now these are commands. I'm going to put COMM over here and horribly truncate it. But those are commands. Those are things that cars can do, and you might have instructions on how a car might do that. Now let's wrap this all up into a class. Maybe with fewer variables so I have less to write. So let's say we have a class called car. And in car, we have color, we have model, we have used, and we have a command called turn on, in which we can turn the car on. Don't worry about the parentheses too much, that's just a syntactical thing that it's a hard habit for me to shake. Anyway, now, let's say, okay, so you can think of classes in this sense like a stencil or a blueprint or even like a cookie cutter. Like, let's see here. I was trying to think of an example, but never mind. Cookie cutter is good enough, right? I mean, that makes sense. Like, you can cut out multiple cookies with a cookie cutter. The cookies can all have different properties. One could be chocolate, one could be a sugar cookie, one could have sprinkles on top. You know, one could have nuts in it. That kind of a thing. They're all shaped the same, though, because of that cookie cutter. So, in this sense, let's say instantiating a class or creating an instance of a class, creating a new example of that class is like cutting out a cookie. So we'll instantiate the car class with a new one called auto1. And that's just called auto1. And this is like a variable name like x or something like that, right? It's just a name that we can keep track of in the code. And let's say auto1 is red. And it's a civic. And yes, it's used. And that's it, right? We stop at turn on. Well, why do we do that? Well, what we've done so far is we've filled in the appropriate values on this. Color, model, and whether or not it's used. Because this is a car, it automatically comes with variables that are color, model, and whether or not it's used. And then it comes with instructions to turn it on. So what we've done here is we've created a new car. I mean, it's new to us. It's technically not new since it's used, right? But we've created a new car that's red, that's a Civic, that's used. If we wanted to, we could access the turn on function later and use it. It would know what to do because it knows it's a car, and so it could utilize these instructions right here. So let's say we created a second one. Let's make it black. We'll say it's a Mustang. And no, it is not used. It is a new car. There you go. This one's Auto 2. They're both cars, right? But now what we've done is we've basically simulated in the computer two different cars. One is red, that's a Honda Civic, that's used. And one is black, a Ford Mustang, that's new. They're both cars, they both know how to turn on. They both know that they have to have a color, a model, and some way of knowing whether or not they're used or new. And we've done all that by creating a class in a very, very simple sense up here. This is not how it would be coded necessarily, but this is from an example viewpoint. We've used our blueprints, and we've filled it in with the appropriate information. So now we could create any number. We could go auto 3 and all the way down to like auto 1,000,000. And we would have at that point we would have created 1,000,000 different cars. I mean, at that point you'd probably find some way to streamline it and automate it so you wouldn't have to enter in 1,000,000 cars manually. But you've entered in 1,000,000 cars. Each of them have one line, and that's all it takes. Now, what's the advantage of that over procedural? Well, in procedural, let's look at our 10, 20, 30. I'm going to use basic again. I'm really not trying to rag on basic. It's just, you know, it's an easily accessible example. So let's say we were doing this in basic. So we'd create a car1 for color. We car1 color, and we'd set it equal to red. And then we do car1 model. I know my writing is atrocious right now, I apologize. Civic. And then we do car1 used. We set it equal to no. Then we do car2 color. Oh my gosh, and you get the idea here. In addition, we'd probably also have to insert some lines into right here to tell the car 1, how to turn on. To complicate matters more, that's supposed to be a C. I made it look like a K. Good lord me. In addition, once we've established car2 color and car2 model and car2 used and all that stuff, we'd have to do, you guessed it, car2 turn on. Now what if we had a million cars? It's looking a little tedious now, right? Like a little bit, like maybe 100 years to make tedious. Yeah, so you get where I'm coming with this. The advantage of object-oriented languages is it allows you to have blocks of code, snippets of code, things like that, that are repeatable. Not only that, as we'll see later on, you can also use those blocks of code to communicate with other blocks of code. And as we kind of saw an example here, you can use blocks of code to make copies that then communicate with your original blocks. You see where I'm going with this. It requires less repetition on your part. Now, there is an advantage to this end over here, despite my, glowing description of object-oriented programming languages. To be fair, this is a huge advantage for object-oriented programming languages, is that ability to, repeat code bits and stuff like that. It's possible to repeat code bits in procedural, just not to the extent that you can here. Anyway, the advantage over here in procedural is that, let's say you're just writing a program that says hello world, and then adds 3 plus 2, prints it to the screen, says potato 3 times, and then crashes. Well, it would be insane if we were using object-oriented programming language, an object-oriented programming language, to create a class potato, to create a class math, to create all of these classes and stuff like that that contain all this information that we're probably never going to use more than once. Construct it all, and then have the program run. If we were to go that route in object-oriented programming language, it would be horribly inefficient. We could do the same thing in this procedural language, or procedure-based language, with, 4 lines of code, probably? Ish? 4 lines of code could achieve the same thing, when if you're going nutso and creating classes for everything, and, having everything pass back and forth and stuff like that, and functions and whatever, in object-oriented programming language, you could be looking at like 15 to 20 lines of code, which doesn't seem like that much, but again, those classes are simple. So in that sense, smaller programs benefit more from procedure-based programming languages. And I did it again. I spent 35 minutes talking about object-oriented programming languages. But now you know one of the basic tenets of programming languages and the difference between them. Real quick, we're going to do another one, which is called variable typing. I swear this is going to be super quick, and we're going to get started on actual coding. So like I said, variables can hold a bunch of different stuff, right? They can hold numbers. They can hold letters. They can hold words. They can hold true or false values. But wait, not only can they hold whole numbers, they can hold decimal numbers too. That's supposed to be a period there. And, not only can they hold a true-false value, but the true-false value, whatever. Anyway, these are 5 different types of data that can be stored in a variable. Now, the question becomes, how do you represent 5 different types of data with ones and zeros? I mean, you've only got 2 1 or you've only got two values, either 1 or 0. And, that was a pretty tricky question initially. How do you represent that? Well, it comes down to variable types. Let's say you and a friend are passing notes in class, which I don't recommend, but let's say you are. Let's say they're secret coded notes. So, in case the teacher grabs it, they're not going to be able to see all of the things that you're saying about the class or whatever, or how you're going to go home and play video games, or whatever the case may be. So you've got codes in there, right? Well, how's your friend going to know how to decode your note unless you include some key to it? That you can say like, oh, on mine, if it starts with a B, then you take everything that's written and you move it back 2 letters in the alphabet. That's a Caesar cipher. I mean, it's super simple, but, whatever. Or like, if it's a C, you move it back 3 values. And so on. You get the idea. Basically, there's something in the beginning which determines how to interpret the rest of the secret note. Well, that's what types kind of are like. It basically says, this area of memory, interpret it this way. So you could have the same string of binary values, and you could read it as a 6, or you could read it as a decimal number, or you could read it as a character, or you could read it as the beginning of a string, or you could read it as a Boolean value. And that's what these are called, by the way. Integer for whole number, float for floating point. Basically just means that the decimal point can move around, so you can have like really big or really small numbers. Character for characters, string for text, and that's because it's a string of characters. It's a bunch of characters all in a line, so it's a string of characters. That's where the name string comes from. And then this one has a funny name. It's called Boolean, or bool. And it's just named after a guy, and it means Boolean values can only hold one of two things, either a 1 or a 0, a true or a false. But anyway, these are the types of the variables. If a programming language is strongly typed, you have to declare what type of variable it is before you name it. So in a strongly typed programming language, I might say int x. Then the computer knows from here on out that x is going to hold integers and is only going to hold integers. That can never change. I mean, as with everything, there are exceptions to the rule. Don't get caught up in those. Just for now, that will never change. If we declared it a float, we would know it'd have to hold decimal numbers, always and forever, never change. So if this was a float, the way this would rectify itself is this would actually be 6.0 in order to have that decimal place in there. And that's how it would be represented on the screen. If it was a character, we'd have to put a character in there, and so on and so forth. You get the idea. If a language is untyped, you can just go, and that's it. You don't need anything over here. And the compiler looks at this and goes, and goes, I think that's an integer. Okay, cool. And it'll kind of just figure it out on its own and interpret it appropriately. The advantage of this being there's more flexibility when you're programming. There's more, you can work with this stuff more easily. Disadvantage being it doesn't really have any protection, so you can do some really, really weird stuff on accident. And there is like kind of a security risk associated with it as well. Like somebody could, if they really wanted to, could use the code to do harm to your computer, but that's rare and that's complex, and the programs we're writing aren't going to have that much power anyway. I mean, we're talking like you would need to have a programming language that had access to like the base memory on your computer or something like that, which Python isn't going to have. So I wouldn't necessarily worry about that. But just keep in mind that that's another thing that typed languages have over untyped ones. But again, that flexibility that untyped languages have is pretty cool. So anyway, with that in mind, now that I've talked your ear off about programming languages, I'm going to have you guys go to codecademy.com. And there I'll just put the link into the question box. So you guys should be able to click on it, I think, or at least just copy paste it. And then you'll have to create a username. It'll be your email address. That shouldn't be too bad. And then once you've done that, you can scroll down and there's an option for Python, and we're going to get started with Python. And I'll go along with you so that we can talk about like some of the other things that are going on in there. Basically, it's just an opportunity for me to talk your ear off more. I apologize in advance. Alright, and I'm just going to go ahead and click on it here and get started. And let's see here. Make sure I've gone all the way back to the beginning. Once it loads, I don't want to skip around on stuff. Alright, lesson 1. And I think all the code's already been reset on these, so I don't have the answers pop up immediately. But this one's pretty simple. It's just print. And you guys should already be familiar with that. And then we've got the quotation marks here. The double quotes mean that whatever's inside of them gets printed out to the console over here. Okay, we can't type on it. I thought maybe we could. But that's it. The double quotes are necessary. Oh, you're currently 14%? Well, continue along with where you are on it and make some more progress. Learn a little bit more about methods and stuff like that. Yeah, because methods are pretty cool too. But basically, just anything inside the double quotes gets printed out to the screen, which is another thing about how explicit you have to be with the computer. You have to tell things to print out to the screen. It's never going to print stuff out on its own. The note at the end here again is something that's the computer is being told to do, and it's part of the Python programming language. Basically, it outputs any like issues you might have. Here's a variable, and again, note how there's no type in front of it. Python is untyped, and this is how you set it equal to something. Really simple. Done and done. Actually, I wonder. Oh, that also works. Okay. Now here we've got a few instances of how Python interprets different types of variables, and you'll notice that they're called myInt, myFloat, myBool. These are just names. It's not actually being typed. The typing is happening by the Python interpreter. It's figuring out what those should be. We're just giving them helpful names for ourselves, which is good coding practice. Let me tell you, things with helpful names, pretty excellent. None, again. And here you can see a super easy way to just change the value of a variable. Just set it equal to something else. That's all it takes. which is ridiculously easy. Um, and that's nice for Python. Um, so it gets to the point where if we print my integer here, it should it should print 3. At some point during the program, my int is 7. We just never see that though. That just happens behind the scenes. There you go, 3, and that's it. Nice and easy. Start next lesson. There we go. Oh, wait. Ah, okay. So this is an introduction to one of the important things about Python, and that is white space is king. And what do I mean by that? Well, basically, in most other programming languages, the way you format everything doesn't really matter. So, like, if you think back to our HTML class and how we could be like, and just put all this stuff on the same line. It's like, hello, welcome to my web page, blah, blah, blah. All of that on the same line, and it didn't matter, right? We could either do that, or we could format it nicely. But in the end, it was all translated the same by the computer. And that's usually because there are things like these tags here. In some programming languages, they might be brackets, or curly braces, or parentheses. And they just sort of separate everything out. And because of that, white space doesn't matter. You can format it however you'd like, although hopefully nicely. In Python, you don't have those. I mean, you have some parentheses here, but that's not related to organization. So because of that, white space is important. You need to have white space in order to organize your code, in order to tell where things are sort of like lie in the pecking order, so to speak. That sounded really classist, but that's not really what I meant to have it sound like. But anyway, you'll notice that there is an error that returns here. Wonder what's happening. Well, let me tell you. Oh, and it already revealed. Oh well, whatever. This DEF stands for define, or definition. And then we're defining a method called spam. Now, this spam method is just like our honk horn. Good lord. Or like turn on methods. It's literally, it's a list of instructions that we can refer to whenever. In this case, it sets a variable called eggs equal to 12, and then it returns the value of eggs to whatever calls it. So basically it sends 12 back to whoever's calling it. Down here, we have a print command. And this gets a little weird, but bear with me here. So we're printing whatever the result of the spam method is. So the computer goes, oh, okay, this is the thing, this exists, alright, cool. And then it goes down here, it's like, alright, print. What am I supposed to print? Bring it. Throw it at me. And then you go, spam. And it goes, oh, okay, I looked that up earlier, what's spam? So then it goes back up here, and it goes, okay, eggs equal 12, alright, got it. Alright, return. Oh, okay, cool, return. What are we returning? We're returning eggs. And then it goes, okay, so eggs is equal to 12, right? And it throws 12 into here. So after you break it down, basically what's saying is it's going to print 12. Now you can see why procedural programming languages might be easier, because to do all that, we could have done one line of code that was just print 12. But, or print eggs, eggs equals 12, and print eggs, 2 lines. But this is a good framework for more complex code that you might have. So this one's just talking about the interpreter, nothing crazy. And then it's asking us to set spam and eggs to Boolean values, true and false, respectively. Little side fact about Boolean values. False is always going to be 0. like everywhere and forever. Uh, so you can, with many programming languages, in fact, you can either enter in false or 0. In some programming languages, it requires you to enter in 0. You can't even enter in false. True, on the other hand, is anything that's not 0. Some interpreters or compilers have a restriction on them. They say that true has to be 1. It cannot be any other number. Some aren't so finicky. Some, you could have negative 295, and that would be true because it's not 0. You could have positive 1/5, and that'd be true because it's not 0. You get the idea. I mean, you couldn't really, yeah, well, I don't think you could really do that. But anyway, any non-zero value for some compilers is true, which can also create some weirdnesses, so keep that in mind. And then number 8 introduces comments. I don't know if I can say enough about comments. Comments are incredibly important. Comments are so helpful. Comments will save your life. You'll be thanking yourself or whoever's written comments in there anytime you see them, because they aren't used nearly enough. Well, basically all comments are lines that are invisible to the computer. You can see them, but they're invisible to the computer. It's like writing in the margins of a book. In Python, you use the pound sign or the hashtag, depending on your preferred nomenclature. If you really want to get fancy with it, you can call it an octothorpe, which is, I believe, its original name. Anyway, the pound sign means that this is invisible, so I can write notes myself. I can say, oh, mysterious variable holds the number of times. Put another pound sign to do a new line. My cat meows in a given hour when he's bored. So now I know what mysterious variable means, which is great if this were like 10,000 lines of code, and I started writing it like 2 years ago, and I came back to it 4 months ago, or the last time I touched it was 4 months ago, because you're never going to remember everything that you did. You're going to sit there and you're going to go, why did I do that? That didn't make any sense. And you're going to fiddle around with it, you're going to sort of move things here, move things there, and everything's going to break, and you're going to go, what did I do wrong? Oh, geez, why did I do that back then? That must have been what made sense. And then you'll look at it again, and you get the idea. It's even worse when you're looking at somebody else's code, because even if you guys use the same formatting styles, you know, you guys all took the same classes, you all read the same books, you learned from the same instructors, you go out there and you make a programming or write a programming assignment. You both are going to tackle the problem in 2 entirely different ways. And they can be different enough that you'll pull up their programming assignment, and you'll go, huh? What? What are you doing? How does that make any sense? That doesn't make any sense. And if they commented it, well, then you'll just be infinitely thankful. So that's a single line comments. You can also comment over multiple lines with 3 double quotes. So just 3 of them together. You'll notice it keeps going until I put 3 more double quotes. And that just makes it easier in case, you know, you're writing like a long explanation about what a block of code does or something like that. You can open it up, write a bunch of stuff, and then close it, rather than having to, you know, do this for each line that you're typing a comment, because that can get old. Some people prefer to do that because it makes it look nicer, but it's personal preference. And we accidentally jumped over that one. There we go. And this is where you get to the real meat and potatoes of variables, is setting them equal to math equations. So in this sense, instead of setting count2 to an explicit number, we set it to the result of a mathematical equation, in this case 90 plus 80. Now you can go even crazier with this. You can set it equal to adding two more variables together, and then you can set those variables equal to the product of three other variables, and then you can set those equal to two numbers adding together, and then you can set one of those variables equal to like the time of day, and then so everything just kind of changes and stays fluid throughout the span of the computer. Like you might have a variable called hero health, and you might set it equal to hero health minus monster attack. And there you go. You've got two variables which change over the life of the program, probably, and update themselves constantly. Hero health might have 90 in it, might have 80 in it, monster attack might have 15, Anyway, let's do that. 170. And also, as a final note for today, you can use exponents in Python by hitting the multiply sign twice, which is really nice that it's built into Python. Some other languages it's not actually built in, and you need to include libraries, which libraries are basically blocks of code. They could be lines or whatever. They could be pages and pages and pages of code that other people have written and released so that you can include them and increase the functionality of your program. So in like C, you need to include a math library in order to be able to use exponents. Just silly, but that's how it goes, because C assumes you don't need anything necessarily. C assumes that maybe all you need is like the most basic math operations, and then you can build it up from there. Anyway, that's going to do it for today because it's 8:59. Next week, we should be getting started on Raspberry Pis. So hopefully you guys will have your Raspberry Pis from lab. And just remember for Monday to get some kind of like monitor and keyboard and stuff like that that you can hook up to your Raspberry Pi so that you can use it. If there's no way, like if you can't just get like a cheapo monitor and like a beater keyboard and mouse or whatever, then that's okay. You can still watch the lessons or whatever. They just might be less interesting because a lot of it is about programming directly onto the Raspberry Pi and setting it up to get Minecraft Pi ready and everything like that. But anyway, poll questions. If you have any questions, feel free to ask me, and then we'll break for the weekend.